Good afternoon. Today we will begin a new chapter, Determinants. It is an important part of your class 12th syllabus and it is very useful in higher mathematics, especially in matrix algebra, coordinate geometry and calculus. By using determinant, we can solve the linear system of equation. Okay. So let's start this new chapter, Determinants. So at first we see what is determinant, then how we calculate determinant of matrix of order 1 and of matrix of order 2. I hope you are familiar with matrix. Then we do some example and then find a determinant of matrix of order 3 cross 3 and some example. Okay. So where we use determinant and what is the application of determinants? So if you know, if we want to solve any linear system of system linear equation, we can solve it by algebraically. There is many method to solve it, but they are very linear method and it takes so much time to calculate to solve the system of linear equation. So if we use determinant to solve system of linear equation, we can solve it. Okay. So at first, if there is given a system linear equation just like it a1x plus b1y equal to c1, a2x plus b2y equal to c2. So we can represent it in a matrix form. Okay. So what is matrix representation? It can be written as a1, that is a coefficient of x, and b1, coefficient of y in first equation. Then a2 is coefficient of x in second equation. Then b2, that is a coefficient of y in second equation. X and y are variable that we need to find, and c1 and c2 are the constants. So by using matrix, we can represent a system of linear equation. Okay. As we know, if we multiply this matrix x and y, we get a1x plus b1y in a matrix. Then second row is a2x plus b2y is equal to c1 c2. If we comparing both sides, we again get a1x plus b1y equal to c1, a2x plus b2y is equal to c2. To understand determinant, we must know how matrix looks like and how we multiply in matrix. Okay. So the system of linear equation has a unique solution if it depends on the value of a1 b2 minus a2 b1. The uniqueness of the system solution depend on the expression a1 b2 minus a2 b1. If a1 b2 minus a2 b1 is not equal to 0, that is a1 by a2 not equal to b1 by b2, then this system has a unique solution. Okay. So if we have a system of linear equation, we can solve it by algebraically and any other method, apply it and find the value of x and y. And we can write it as a matrix form, that is a1 b1 a2 b2 x y and equal to matrix c1 c2. So we can relate it by an expression, and that expression is a1 b2 minus a2 b1, and that expression is known as determinant. And by this expression, we know this system has unique solution, many solution, or no solution by using this expression. So if we calculate this value a1 b2 minus a2 b1, we know about the system of linear equation. So this expression is important for us, and that expression is called determinant for the matrix a1 b1 A2, B2. Okay. So, system of linear equation has unique solution if this expression is not equal to 0. That is, it can be also written as, we know this condition, that is A1, A2 is not equal to B1, B2. If then system of equation is no solution, that is A1, B2 minus A2, B1, that expression is not equal to 0. Then we have a conclusion that the system has a unique solution. Now, so let A is equal to a 2 cross 2 matrix. 2 cross 2 matrix means number of rows is 2 and number of column is also 2. So the matrix is A1, B1, the first row, and A2, B2 is second row. And if we take vertically, A1, A2 is first column and B1, B2 is your second column. Okay. So we can relate determinant by system of linear equation. We can solve system of linear equation algebraically and also by using determinant. So we see two system of linear equation, a1x plus b1y is equal to c1, a2x plus b2y is equal to c2, and then we represent in a matrix form, and then we relate it with an expression, that is a1 b2 minus a2 b1, and we see if a1 b2 minus a2 b1 is not equal to 0, then the system of linear equation has a unique solution. So this expression is important for us, and that expression is called determinants. Okay. So if there is A, that is 2 cross 2 matrix. 2 cross 2 matrix means 2 rows and 2 columns. Rows are horizontal, that is A1 B1 is first row, A2 B2 is second row, and the first column is A1 A2 and second column is B1 B2. Then the number A1 B2 minus A2 B1 is called the determinant of matrix A. Okay. And if this value, that is determinant, is not equal to 0, then the system of linear equation has a unique solution. So by using determinant, we can solve the system of linear equation. Okay. So it is noted as DET A and read as determinant of A. Determinant have wide application in fields such as engineering, science, economics, and social science. Because if we want to solve a system of linear equation, we can use determinant. Suppose there is a linear equation with 100 variables, then we cannot solve it by algebraically. So we use determinant to solve the system linear equation and find the values for the variable. Okay. We also use the determinant to find the value of area of a triangle. We can use determinant to find, if there is 3 vertices, you can use determinant to find the area of the triangle. So the determinant has wide application in today's life. Okay. To every square matrix A represent as square bracket Aij, where Aij is the element of the matrix of order n, that is n cross n rows and n column. We can associate a number, real or complex, called determinant of the square matrix A, where Aij is I and jth element of A. Ij represent the element position in a matrix. If there is a matrix, then first element, that is A11, represent the element of first row and first column, that is A11. If element A23 is, the value of I is 2 and 3 is j, so A23 represent the element in the position of where the second rows and third column intersect. Okay. So we can represent a square matrix A as square bracket Aij of order n. And each square matrix, carefully see, we only define determinant for a square matrix. We cannot define it for any other matrix. We only define a determinant for a square matrix. Okay, so we can associate each square matrix with a real or complex number, and that real and complex number is called determinant. We see how we can relate. Just like if we have a matrix of order 2 equals 2, then we can relate it with a number. That is, let's suppose this is number 3 that is related to this matrix. And that number 3 that is unique for that matrix, and that number can be real or complex, and it is called determinant. Okay. So we can think it as a function which associate each square matrix with a unique number. So what is function? We define a function as from a set to another set. The first set is called domain, another set is called codomain, and for each element of domain there exists a unique associate a unique element to the codomain, and that element belong to the codomain, and the set of all images is called range set. So we can relate it as a function. We define a function from set of all square matrices to a set of real and complex number. So each matrix we take and it associate with a unique number that can be real or complex. So finding a determinant for a square matrix can be consider it as a function. Okay. If M is the set of square matrices, we consider M which contains all the square matrices, and K is the set of number, real and complex. Okay. So now define a function. Function, just take a matrix from M to K, is defined as Fa is equal to K. So where A belongs to M and K belongs to small k belongs to capital K, then Fa is called the determinant of A. This is a mathematical representation of function, that is a function f which is determinant. So determinant defined from M, we take a matrix from M that is A, and we map it with a element. That element comes from the set K, and we just associate it, combine it, or we can say we relate that matrix with that number. So we relate a matrix A with a number K. Okay, we just map it a matrix with that number. Then that number is called determinant. Okay, and that number can be real or complex. Is noted by bar A, and it is read as determinant of A, or it is also denoted by triangle shape. Okay. If A is equal to 2 cross 2 matrix, and that matrix is A, B, C, D, then determinant of A is written as determinant of A is equal to determinant A, B, C, D is equal to determinant of A. Okay. For a matrix A, the A is this representation is read as determinant of A, not modulus of A. Okay, the modulus sign is also same as determinant. So if A is a matrix, then it is read as determinant of A rather than modulus of A. Okay. Second case remark is only square matrices have determinants. We cannot define determinant for matrices with uneven order that are not a square matrix. Okay. So determinant is just a number that is related to a matrix. For a unique matrix, there is a unique number. Okay. Each square matrix is associated with a unique number. If we want to find a determinant of 1 cross 1 matrices, 1 cross 1 matrix, so it has a is there is only one element in that matrix. So let A is equal to matrix square bracket A be a square matrix of order 1, that is 1 row and 1 column. So there is only one element. So in this case, the determinant of A is defined is to be equal to A. That is, determinant of A is equal to A. Okay. Now if example for A is equal to matrix minus 5. Order is 1 cross 1, that is 1 row and only 1 column. So there is only one element, that is minus 5. Then determinant of A is equal to that number, that is A. So determinant of A is minus 5. Okay. So if there is a matrix of order 1 cross 1, then determinant is just that element, that is minus 5. So from this example, we can relate the definition of determinant of as a function that we take a matrix of order 1 cross 1 from element from set of all square matrix M, that is A, that is minus 5, and then we relate it, we associate with a unique number, that is minus 5, and minus 5 comes from the set K. So we take it as a function we define from a matrix set of all matrices to a set of real number or and complex number. Okay. If b is equal to x, where x is a variable, and the order of this matrix is 1 cross 1, and we have to find determinant of b. As we know, if A is equal to a 1 cross 1 matrix, the determinant of A is determinant of A, that is equal to A. So determinant of B is equal to X. Okay. Now we have to find the determinant of matrix of order 2. So if we have a matrix of 2 cross 2, then the determinant is product of diagonal elements minus the product of off diagonal elements. Okay. So let's consider a matrix A of 2 cross 2, that is A11, A12, A21, A22 with vertical lines, and these vertical lines represent determinants. The square bracket represent the matrices, and if there is a this vertical lines, then it represent we have to find determinants of that matrix A11, A12, A21, A22. Okay. And this 1 1 1 2 2 1 2 2 represent the indices or the position of that element. A22 represent that A22 present at the position of second row and second column. First, if AI is a, I represent the row in which row it is present, and J represent the in which column it is present. Okay. So for each element, there is a unique position for that element, and we can find that position by the value of I and j. So determinant of A is equal to A11 into A22, product of diagonal element, first one, and then minus subtract product of off diagonal element, that is A12, A21. So if we want to find the determinant of 2 cross 2 matrices, A is equal to, like A is equal to A11, A12, A21, A22, just multiply the product of diagonal element minus product of off diagonal element. First take A1, A22 as it represented by the arrows. Take A1, A22 and then minus second arrow A21, A12. Okay. For example, evaluate the determinant of 2, 4, minus 1, 2. So order of this matrix is 2 cross 2. And the elements are 2, 4, minus 1, 2. So 2 and 2 are the diagonal elements and 4 and minus 1 are the off diagonal element. So we know that if A is equal to A11, A12, A21, A22, then determinant of A is given as A11 into A22 minus A21 into A12. So as here elements A11 is 2, just compare it. A12 is 4, A21 is minus 1 and A22 is 2. Put the value in the formula, then we get determinant A is equal to 2 into 2 minus 1 into 4, that is 4 minus 4. So determinant of A is 4 plus 4, that is 8. And the 8 is the determinant of the matrix for the 2 cross 2, that is 2, 4, minus 1 and 2. Now we have to evaluate the determinant of 2 cross 2 matrix whose elements are x, x plus 1, x minus 1 and x. So just calculate. Okay. So we need to find determinant x, x plus 1, x minus 1, x. So we know that if A is equal to A11, A12, A21, A22, then determinant of A is A11 into A22 minus A21 into A12. So on comparing, we get A11 is x, A12 is x plus 1, A21 is x minus 1 and A22 is x. So by using the formula, determinant of A is A11 into A22, that is x into x minus x plus 1 into x minus 1. When we simplify, we get x square minus 1, that is x square minus x square plus 1. So the value of determinant is 1. Now we have to calculate determinant of matrix of order 3. So a 3 cross 3 determinant can be expressed as a sum of 3 2 cross 2 determinant. That is a basic idea how we find the determinant of a 3 cross 3 matrix. 3 cross 3 matrix means there is 3 rows and 3 columns, and we can express it as sum of 3 2 cross 2 determinant. So to calculate determinant of order 3, we need to calculate 3 2 cross 2 determinants and then sum it to get the determinant of order 3 cross 3. And this process is called expansion, where we break it into 3 2 cross 2 determinants. Let's consider a general 3 cross 3 matrix A, that is A11, A12, A13 first row, A21, A22, A23 second row, A31, A32 and A33, that is your third row. So now we find the determinant of this matrix A, denoted as det A, can be expanded along any rows or columns. So to find the determinant, we can take any row or any column and just expand along that row or that column. So there is 3 rows and 3 columns. So we can take any of these 3 rows and or 3 columns to find the value of determinant. So let's see how we calculate this. So first we expand along a first row R1. The first column is first row is A11, A12, A13. So step 1, for the first element A11, we take A11, multiply the first element A11 of R by -1 the power 1 plus 1, and where 1 plus 1 is the 1 is I and plus j, I plus j. So that are the sum of its row and column indices. So A11, so there is a it is present in first row and first column. So we multiply with the element -1 the power 1 plus 1. Okay, so that is your step number 1. Then multiply this by 2 cross 2 determinant, and that determinant is obtained by deleting the row R1 and column C1 where A11 lies. So A11 lies in first row, that is R1, and first column, that is C1, that is A11, A21, A31. So just deleting these rows from this matrix, we get 2 cross 2 matrix, that is A22, A23, A32 and A33. So the term is -1 the power 1 plus 1, and 1 plus 1 is the row and column indices, into A11, that element, and then the determinant of the matrix that we obtain by deleting the first row and first column. Okay. Now for the second element A12, we expand along the first row. So the first element of is A11 and second element is A12, and then for the second element A12, multiply the second element A12 by of R1 by -1 the power 1 plus 2, where 1 plus 2 is what? The value of I and j, that is indices of rows and column. Then multiply this, that is A12 into -1 the power 1 plus 2 with the 2 cross 2 determinant obtained by deleting the row R1, because we are expanding along the because A12 is present in R1 row, and the column C2 because it is present in column 2 where the A12 lies. So when we deleting R1 and C2, we get a 2 cross 2 matrix, and then find the determinant of that matrix. So the second term is -1 the power 1 plus 2, A12 determinant of A21, A23, A31, A33. We get this by just deleting the first row and second column. For the third element A13, so at first multiply the third element A13 by of R1 by -1 the power 1 plus 3, and then multiply this by 2 cross 2 determinant obtained by deleting row R1 and column C3, because A13 lies in position A13, that is first column and third row, third first row and third column. So now we have three determinant of 2 cross 2 matrices, and the term is minus 1 the power 1 plus 3, A13, A21, A22, A31, A32. Now summing these three terms, expansion of determinant A is the sum of all three terms obtained in step 1, 2 and 3. So determinant of A is minus 1 the power 1 plus 1, A11. For element 1, for first element A11, we just multiply with minus 1 and then power I plus j, that is indices, and the determinant of the matrix when it is obtained by deleting first row and first column. Then plus second, for second element, multiply with first minus 1 the power 1 plus 2, and then the determinant of the matrix obtained by deleting first row, second column. Just imagine in the matrix A, how when we delete the entire row and entire column, we get the matrix A21, A23, A31 and A33. And for the third element, when we multiply with minus 1 the power 1 plus 3, A13, and then the matrix obtained by the deleting first row and third column. So we get A21, A22, A31 and A32. And when we combine this all, we get the determinant of 3 cross 3 matrices. Okay. So if we want to calculate a determinant of a matrix of order 3, we need to calculate determinant of 3 2 cross 2 matrix. Okay. Now simplify the minus 1 the power I plus j terms, which determine the sign. As a determinant of A is A11, and then we just calculate the determinant of order 2 cross 2, and that is product of diagonal element minus product of off diagonal element. So we get A22 into A33 minus A23 into A32. Then minus 1 the power 1 plus 2 is minus 1. So minus A12 into A21 A33 minus A31 into A23 plus A13 minus 1 the power 1 plus 3 is plus into determinant of A21, A22, A31, A32, that is A21 into A32 minus A31 into A22. So determinant A is equal to A11 into A22 into A33 minus, just expand, A11 A32 into A23 minus A12 A21 A33 plus A12 A31 A23 plus A13 A21 A32 minus A13 A31 A22. That is the determinant of matrix 3 cross 3. Okay. Now expansion along selected row R2. So at first we expand along row R1. Now we expand along the second row R2. So the matrix determinant, we have to calculate the determinant of matrix A, and that is matrix is A11, A12, A13, A21, A22, A23, A31, A32, A33. When we cancelling our rows and column, that we when I say that cancel first row and second column, just picturize this matrix and just cancel. If I say cancel the second row, then A21, A22, A33, just cancel the entire row. And when I say cancel, and then also I say cancel the third column, then cancel the A13, A23, A33. So when we cancel it, A21 is gone, A22 is A23, A13 and A33. So we just left with A11, A12, A31, A32. So understand how we cancel the rows and column. Okay. So now we expand along second row. We already expand along R1 and we get the value determinant. And if we, as I already told you, we can calculate determinant of a matrix by expanding any row and any column. Okay. So just verify, if I expand along second row, can I get a same value or it is different from when we expanding along first row? Okay. So just apply the same principle as I do in expansion along R1. So we get determinant of A is equal to minus 1 the power 2. So second row is A21. So for A21, we get minus 1 the power 2 plus 1. The value of I is 2 and j is 1. So minus 1 the power 2 plus 1 into a21, then determinant of a matrix that is obtained when we cancel a21. So second row and first column. So we get a12, a13, a32 and a33. For the second element a22, just see in a determinant A, the whole matrix. So for a22, we multiply with minus 1 the power I plus j, that is I is 2 and j is 2. So minus 1 the power 2 plus 2 into a22. And the determinant of 2 cross 2 matrix, determinant is obtained by just cancel second row, that is a21, a22, a23 and second column, that is a12, a22, a32. So when we cancel, we just left with element a11, a13, a31 and a33. Okay. For the third element a23, we multiply with first minus 1 the power I plus j, that is minus 1 the power 2 plus 3. So into a23, so determinant of, then we just multiply with the determinant of, that is obtained by just cancel second column, that is a21, a22, a23. Just picturize in the matrix A. Okay, then you understand how we get 2 cross 2 matrix. So when we cancel a21, a22, a23 and the third column, that is a13, a23 and a33, we only left with a matrix a11, a12, a31 and a32, and that is your 2 cross 2 matrix. Okay. So by using the formula for 2 cross 2 determinant, that is product of diagonal element minus product of off diagonal element, we get the determinant of A, that is minus a21, the determinant of a12 into a33. Just multiply the diagonal element minus determinant of off diagonal element multiply. So a13, a32 into a13. Similar for the second term, minus 1 the power 2 plus 2 is plus into a22, then a13 into a33 minus a31 into a13 minus 1 the power 2 plus 3, that is minus 1 into a23. Then just multiply a11 into a32 minus a31 into a12. Okay. Further expansion and rearrangement, we saw the determinant of A is this. Okay. Now, so we get determinant of A is, just rearrange the terms. First multiply a21 with all, open the brackets, multiply with them, and for the expansion we get this arrangement, and when we rearrange we get a11, a22, a33. According to the first element, we take first a11, that is the first element of the matrix, and according to that we arrange it and we consider it as equation number 2. Okay. Now we expand along first column. So the first column is a11, a21, a31. So using the same determinant, when we expand along the first column, the first element is a11. So we consider the element a11, multiply with minus 1 the power I plus j, the value of I and j is 1, 1, so 1 plus 1, and then multiply the with determinant of 2 cross 2 matrix, and the matrix obtained by cancelling first row and first column. That a11 says that a11, so I and j value is 1, 1. So according to that we get the value of minus 1 the power I plus j, that is minus 1 the power 1 plus 1, and that ij says, and according to that ij, just in element a11, that I is 1 and j is 1, so it says that just cancel the first row and first column to get the 2 cross 2 matrix and find the determinant, and just multiply with a11 into minus 1 the power 1 plus 1. The second element of that column 1 is a21. So the value of minus 1 the power I plus j is minus 1 the power 2 plus 1, minus 1 the power 3, that is minus 1, into a21, and then determinant of the matrix, which is obtained by just cancelling the second column, row and first column. So we get the matrix A12, A13, A32, A33. Then third element of column 1 is A31. So we multiply with minus 1 to the power 3 plus 1 and then multiply with the determinant of order 2 cross 2, which is obtained by cancelling or deleting the element, deleting the row, third row and first column. Okay. So by using the formula of 2 cross 2 determinant, just expand it, we get minus 1 to the power 1 plus 1 is positive. So just multiply the diagonal element minus of diagonal element, we get this expression. Now further expansion and rearrangement confirms that A is equal to this. Okay, just solve the bracket, remove the bracket and expand and rearranged the terms, we get this. We rearrange the terms because the what we consider is equation 1, equation 2 and equation 3, all threes are equal. Since clearly the values we obtained in 1 to 3 are equal, so this demonstrates that a fundamental property determinant that expanding a determinant along any rows or column gives the same value. Okay. So if the general formula is to calculate determinant, we expand along first row. So we take first element A11 plus determinant of 2 cross 2 matrix left after removing first one and column 1 minus second element, that is A12, determinant of 2 cross 2 matrix left after removing row 1 and column 2 plus A13 into determinant of 2 cross 2 matrix left after removing row 1 and column 3. Okay. So whenever you have to find the value of determinant, so if we expand along, we can expand along any rows and column. Okay. And when we expand along any column, so take that first element and then into determinant of the matrix that is come after removing that indices, rows or column. Okay. So formula for determinant is first element A11 into determinant of the matrix that is obtained after removing row 1 and column 1 minus A12, A21, A23, A31, A33 plus A13 into A21, A22, A31, A32. Okay. Just expand and using the property of determinant of 2 cross 2 matrix, we find the formula for calculating determinant of 3 cross 3. Sign convention for expansion, the sign of element of aij is minus 1 the power I plus j. Okay, for any element of aij, the sign is just minus 1 the power I plus j. So for row 1, minus 1 the power 1 plus 1. Okay, so we do some remarks. So for easier calculation, expand the determinant along the rows or column which has the maximum number of 0. The value of determinant remain the same regardless of the rows or column chosen for expansion. So we can find determinant by choosing any row or column. The value determinant remain same. While expanding, instead of multiplying by minus 1 the power I plus j, we can multiply by plus 1 or minus 1 according as I plus j is even or odd. Because if I plus j is even, the value of minus I the power I plus j is always plus 1, and if I plus j is odd, the value of minus I the power I plus j is minus 1. Okay. Let A is a matrix of order 2 cross 2, 2 2 4 0 and B is 1 1 2 0. Then it is easy to verify that we can write A as 2B It means if we multiply matrix B with 2, we get a matrix A. So determinant of A, if we find determinant of A, just multiply the diagonal element minus product of off diagonal element. So for determinant of A, we multiply 2 into 0 minus 2 into 4. So we get 0 minus 8, that is minus 8. Determinant of B is 1 into 0 minus 1 into 2. So 0 minus 2, that is minus 2. Okay? Okay. So observe that determinant of A is equal to 4 into minus 2. Just a simple observation. If we see determinant of A is minus 8 and B is minus 2. Okay. So we can write determinant of A as 4 into minus 2 and 4 as 2 the power 2 square, and minus 2 is determinant of B. So we write A as determinant of A as 2 square by determinant of B. So if a matrix A can be written as, so determinant of matrix A is equal to the power n into determinant of B, where n is equal to 2 is the order of a square matrix A and B. Okay, so if there is a relation that is A is equal to 2B, we can write a matrix A as 2B. Then if we know determinant of B, we can calculate determinant of A by this formula, that determinant of A is equal to the power n into determinant of B. Okay, and where n is order of square matrix A and B. Clear? Okay. So in general, if a matrix A is equal to K times B, a matrix B, where A and B are square matrix of order n, then determinant of A is equal to K the power n, where n is order of A and B into determinant of B. Okay, so if there is a relation between a matrix A and B, that is A is equal to KB, and if we know the determinant of B, then we can calculate determinant of A by using this formula, that is determinant of A is equal to K the power n into determinant of B. Okay, now we given a matrix 1 2 4 minus 1 3 0 4 1 0, and we have to evaluate determinant. So recall the formula and evaluate. So we need to find determinant of 1 2 4 minus 1 3 0 4 1 0. So we know that if A is equal to A11, A12, A13, representation of an element on a matrix of order 3 cross 3. So if we expand along row R1 to find determinant of matrix A, we get first element A11, then just determinant of matrix 2 cross 2, which is obtained by cancelling first row and first column, that is A22, A23, A32, A33, then minus sign, where minus comes from the value minus 1 the power I plus j, and since I and j is here 1 and 2 and 1 plus 2 is odd, so minus 1 the power I plus j is become minus 1, and then element A12 and determinant by cancelling first row and second column. Okay, similarly for A13 plus, because 1 plus 3 is even, so we get plus sign here, plus A13 and determinant of matrix 2 cross 2, which is obtained by just cancelling third column and first row, that is A1, A21, A22, A31, A32. So when we expand, when we find determinant of this all 2 cross 2 matrix, we get this formula for calculating determinant of order 3 cross 3. Okay, now we have values for A11, A12, A13 for all till A33. So we just substitute into this formula to get the value of determinant. So when we expand along row R1, we get 1, then determinant of matrix 3, 0, 1, 0. Similarly for minus 2, minus 0, 0, 4, 0, plus 4, minus 1, 3, 4, 1. Now find determinant of this all 2 cross 2 matrices. So we just multiply the diagonal element minus of diagonal element. So 3 into 0, minus 1 into 0, minus 2, minus 1 into 0 into 4 into 0, plus 4, minus 1 into 1, and 3 into 4. So we get 1 into 0, minus 2 into 0, and 4 plus 4 into minus 1 minus 12. So we get determinant 0 minus 0 plus 4 into minus 13. That is minus 52. Okay, clear? Okay. Now we expand along column 3. As I already tell you that if we expand along any rows or column, we can find determinant by expanding along any rows or column. So at first we expand along row 1. Now we expand along column 3 to just verify, can we get a same answer? So when we expand along column 3, this is a better choice due to the 2 zeros. In this column 3, there is a 2 0 present. So calculation is much easier than comparing to expanding along any rows. Sign for C3 are plus, minus, plus. Plus for the element 4, this position is A1 3 and 1 plus 3 is positive, so is plus. Then 0 is present on the position A2 3 and 2 3 is 2 plus 3 is 5, that is odd, so it becomes negative. And 0 is present in the position of A3 3 and 3 plus 3 is 6, that is even, so the sign is positive. So just determinant is equal to 4 into determinant of just cancelling the first row and third column, we get that matrix minus 1 3 4 1. And similarly for 0 and last element, that is also 0, so we don't even need to calculate the second and third part. So we get determinant is equal to 4 into minus 1 into 1 minus 4 into 3, that is 4 into minus 1 minus 12, that is 4 into minus 13. So determinant is become minus 52. So now we get a determinant which is same as when we expand along R1, that is minus 52. Okay, now we have another matrix of order 3 cross 3 and we have to calculate the determinant of this matrix, that is 0 sin alpha minus cos alpha minus sin alpha 0 sin beta cos alpha minus sin beta 0. So just try. So A is equal to, we know that A is equal to A11, A12, A13, A21, A22, A23, A31, A32 or and A33. So when we expand along R1, we get determinant of A, that is A11 into A22, A23, A32, A33. That is just cancelling the first row and first column. Okay. Similarly for element A12 and A13. So we get a formula for calculating determinant when we expanding along R1. So that is the formula. So to evaluate determinant of given matrix, when we expanding along R1, we get first element is 0 and then just cancelling first column and first row, we get a matrix of order 2 cross 2, that is 0 sin beta minus sin beta and 0. For second element, that is sin alpha and the indices for this element is 1, 2. So 1 plus 2 is odd, so we get minus sign here, minus sin alpha, and now cancelling second column and first row, we get matrix minus sin alpha, sin beta, cos alpha 0. For the third element, minus cos alpha, determinant of minus sin alpha 0, cos alpha minus sin beta. So when we get determinant of this all matrix of order 2 cross 2, for the first 0 into determinant of 0 sin beta, sin minus sin beta 0. Since we multiply with 0, we get 0 minus sin alpha, then determinant of minus sin alpha into 0, that is 0, sin beta into cos alpha minus cos alpha, then sin alpha minus sin beta, minus minus plus, so it becomes sin alpha into sin beta minus 0. So we get sin alpha into sin beta cos alpha minus cos alpha sin beta. So first one is positive sign, negative sign, both are cancel out, so determinant of is 0 for this matrix. Okay. Now we have to find value of x for which 3x x1 is equal to 3 2 4 1. Now, so we have to calculate the value of x, and we have two determinant. First one is 3x x1 and 3 2 4 1, and determinant for both are same. So we just apply the formula for both to calculate determinant. So for the first part, we know that determinant of a1 b1 c1 d1 is equal to a2 b2 c2 d2. So determinant of a1 b1 c1 d1 is a into b d1 minus b1 into c1 is equal to a2 into d2 minus b2 into c2. So then we get 3 into 1 minus x square. Just apply the formula, and for determinant first part, LHS part and RHS part, and then for calculate determinant for 3 2 4 1, we get 3 into 1 into minus 4 into 2. So we get 3 minus x square is equal to 3 minus 8. That is x square is equal to 8. So now we calculate, just take the square sign on the other side, it get square root of 8. So square root of 8 is equal to plus minus 2 into root 2. That is the value of x. Okay. So in today's class, we learn how to calculate determinant of order 1, order 2 and order 3. Okay. Thank you.